I should have. It makes me very grumpy. Because when things are easy, no one ever says that. But when it gets challenging, that's when we say it. And it's okay to be challenged. It's if everything was easy in life, right? It's better to be challenged now when you have this support system than wait till you go to college and that's the first challenge of your whole life and then you drop out of college because you're like, oh my gosh, I never knew things could be difficult. It's better to be challenged now.
This is kind of off topic, but you have to be 35 to be president, right?
Yes, dear.
What?
True fact.
Okay. In 2.7 we had a ruler postulate. In 2.8 we have a protractor postulate, which basically just says every angle has a measurement that corresponds to a protractor. Again, I don't know that we ever really use that in a proof, but it says any angle can be put and measured from 0 to 180. All right. And guess what else? We have an angle addition postulate that's very similar to the segment addition postulate that says if you have an angle, right? If D is in the interior of angle ABC, right? Then when you add these two angles together, it's going to add up to the green angle. So it says, oh look, it's very color coded. Too bad you don't have colors, right? No one ever says in PE class, I'm never going to play dodgeball again in my life. Why do I have to learn the rules of dodgeball?
You don't know that. What if?
Stop with the what ifs.
Just stop.
What about zombie apocalypse?
Just be well-rounded. Like, you don't know. You are however many years old. You don't know what you're going to do with your life yet. You can't make a decision on that. So the nice thing is, the angle addition postulate, there are a lot of homework questions tonight that they don't make you prove things with it. They're just asking you to answer questions, which you probably could have answered without it, right?
Thank goodness.
So it says, find the measure of angle 1 if the measure of angle 2 equals 58 degrees, and the measure of angle JKL equals 162 degrees.
Are you using the numbers with your fingers? Or we should do that, like where we hold up like 3 or 2 or 1.
Oh, okay.
So.
We could do, just so you know, you could do a proof of any problem you ever solved, like everyone, right? This is not a proof problem, but you could really start thinking that way, and you could say, using the angle addition postulate, could I say the measure of angle 1 plus the measure of angle 2 should equal the measure of angle JKL? Is that true? That's the angle addition postulate. And then, could I plug in the measure of angle 2, which is 58 degrees, and the measure of angle JKL, which is 162? What property lets me do that? Substitution. And then what would you do to solve that? Which I know you would not do this unless I forced you to do it. But you could subtract 58. And which one will we get?
104.
C. It always is C in here. Have you noticed that?
Yeah, watch the next one not be C if we told you.
Oh, I see.
So if they say justify your work on a problem like this, you don't necessarily have to do statements and reasons. You can, but you could just show that as you go. And like we could say the subtraction property. So if they ask you to justify, knowing properties and rules makes justifying a lot easier than writing a whole paragraph, in my opinion. Okay, I got a lot of like theorems for you today. That apparently I didn't put boxes around for you to fill in.
I was gonna ask you if you had a box. I was like, oh, she put it.
The supplement theorem and the complement theorem. Again, I think things that should make sense to us here, if we remember what they mean. It says if two angles form a linear pair, then they are supplementary angles. Do you agree with that statement? Two angles form a linear pair, then they are supplementary. You got to know that vocab. Linear pair or make a straight line. Supplementary, add up to 180. So that's a theorem now. So if you get a given information that says two angles are a linear pair, you can say right away, you know, they add up to 180 because of this. And the same thing with a complement. If the non-common sides of two adjacent angles form a right angle, then the angles are complementary. And again, you have to know that complementary means add up to 90. If you said definition of complementary angles as opposed to complement theorem, I'm okay with that. Again, I don't care about these numbers out here. If you want to use the numbers in your homework, you can, but on your test, you're not going to have those numbers. So that's why I would say like complement theorem, or if you forgot it was called a theorem, you could say definition of complementary angles. So let's look at this one. The diagram shows one square for a particular quilt pattern. If the measure of angle BAC equals the measure of angle DAE equals 20, and the measure of angle BAE is a right angle, find the measure of angle CAD. Again, I need to check how your homework is worded here. They say justify. Oh, I have an example 4 that says justify. Which is kind of like a verb, right? Justify, that's the key idea that we have here.
I totally just made it up.
I want more than the answer, so talk me through the answer. Like if you were going to kind of go here. Guys, we need to focus more, okay? So talk me through your answer. How did you, I don't want the answer. I want to know what you did to get your answer.
So the given is the whole bottom sentence.
The whole bottom sentence, yes. So could I label some stuff up here?
Yeah.
What could I label?
BAC equals 20, and then DAE, and then DAE equals 5. So, and then you would add 20 plus 20, you get 40. And that's an addition problem. And then you get 90 minus 40, you get the subtraction problem. And then you get 50 or
Can you subtract it over? Yeah, we could do that. So 50 is the answer, but know if it says justify your work, you could write all the stuff out you're thinking in words, or I think it makes sense to kind of write a step and say why you did it. So, like, you could say the measure of angle BAC plus the measure of angle CAD plus the measure of angle DAE equals 90. And you could write all the given stuff, but if it just says justify, I'm okay if you don't restate the given. If it doesn't say prove, you don't have to do a formal proof, okay? So I would be okay if you wrote that. And why is that true? The complement theorem. I don't know if that really works there, but I'm going to say that. Or because they just tell us that, right?
it'd be given.
It's a right angle. That is kind of given. I mean, I don't know. It is kind of given, but
Whenever you are doing a proof,
I think
you like run into like that problem where it says if it's a right angle, then when you're writing your proof, like your statements and reasons, then can you say in your reasons because it's given?
if you're restating something that was given to you, yes. If it's exactly what,
It's a given.
yes.
So
So, like, I don't know that this is given, though. Like, if I did this, the measure of angle BAC plus the measure of angle CAD plus the measure of angle DAE adds up to the whole angle. Isn't that the angle addition postulate? If I didn't put 90 in here? That's what I think that is.
I was like, I don't think that'd be given.
I know, I don't either. That's why I restated mine. Angle addition postulate. And then we could substitute what they gave us. We could say 20 plus the measure of angle CAD plus 20 equals 90. And all of that, they gave me that, but now I'm substituting it in, right? So like I would say that substitution. And then exactly what you said, Garrett. You could add the 20 and the 20 together, which would be, it's not really the addition, that would just be like simplifying. Or I would be okay if you said the measure of angle CAD equals 50 at this step. What property would get me to that step? Subtraction, because you could say you just subtract both of those at the same time. I know you could do this in your head really quickly and get to 50. That's good, right? Like, it's nice when you know what the answer is. Justify gives you a little break from maybe doing really hard proofs, but kind of still using those properties and theorems to do that.
If we have something like this in our test, can we do it? Can we set it up like that, or do we have to do the 2 column?
If it just says justify, you don't have to do a 2-column proof. Justify just means justify how you got it. And so you don't even have to set it up like this. You could write out the words your justification, but just know that it's expected that you're still using reasons with it. Okay? All right, I got not that much more problems, just a lot of information. These are all things we've talked about before. They're just kind of putting them in in theorems and postulates and stuff again. So properties of angle congruence. Again, we already talked about that angles and segments can use our same three properties, and then they're just saying that you can use congruent symbols with them too. So our same three go-to, reflexive, symmetric, and transitive, apply to congruent angles as well. So I'm hoping you're feeling pretty good about symmetric and transitive. We've been using it a lot. Like, you're definitely going to use that one a lot. What about on here? I did leave some boxes for you to fill in. Congruent supplement theorem said angles supplementary to the same angle or to congruent angles are congruent. Let's kind of digest that for a minute. Angles supplementary to the same angle or congruent angles are congruent. So, kind of look at these two, the if parts there. If angle 1 plus angle 2 adds up to 180, and angle 2 plus angle 3 adds up to 180, does it make sense that since they both add up to 180 with angle 2, that angle 1 has to equal angle 3? Like, that's the only way it could add up. We could do a proof of that. Like, we could prove that theorem very easily by doing substitution, right? So you could say that angle 2, let's see, angle 1 plus angle 2 equals 180, angle 2 plus angle 3 equals 180. So you could say, because they both equal 180, you could set them equal to each other. That's substitution. Subtraction property, subtract angle 2 from both sides, you would be left with angle 1 equals angle 3. So we could prove that that's true. They just give us that theorem that says it's true. And the same thing with the congruent complements. If two angles are both complementary with the same angle, then they have to be congruent to each other. So angles complementary to the same angle or congruent angles are congruent. And again, we could prove that by the same idea there, because they both equal 90. Substitution, you could set them equal to each other. Subtraction property, subtract angle 5, and you would be left that they equal each other. Definition of congruent means they're congruent. So, do those theorems make sense? They're not postulates, they do have proofs to go with them. So I think using that, I have another example there for you. And it even says prove on this one, right? It says, in the figure, angle 1 and angle 4 form a linear pair, and angle 3 plus angle 1 equals 180. Prove that angle 3 and angle 4 are congruent. So prove, if it says prove and not justify, it means you need to either write out a paragraph proof or do your 2-column proof. I'm doing 2-column. I just like it better. Anyone in here like paragraph proofs better?
I kind of like both.
It's got letters and probably paragraph.
I feel like when I do a paragraph proof, I do exactly what I would do in a 2-column proof, but it just takes me way longer, so that's why I think that's the kind of brain that I am, as I like nice organized columns. What's my given here?
Angle 1, angle 4, linear pair, and measure of angle 3 plus measure of angle 1. Doesn't linear pair mean
It does, but that's not what they told us, but we're going to need to say that. Just like on the proof we did on the homework quiz. It said it's a midpoint, so I'm with you. The very next thing I'm going to do is I'm going to change angle 1 and angle 4 form a linear pair. I'm going to change it to an equation, because that's what I'm going to work with. All right, so that's what you want to think about as you're looking at the given information. And they tell me that angle 3 plus the measure of angle 1 equals 180. So using exactly what Mackenzie just said, angle 1 and angle 4 form a linear pair. So can I say angle 1 plus angle 4, or I guess I'm supposed to say measure of angle 1 plus the measure of angle 4 adds up to 180? And I think we just said there was a theorem for that. I always kind of feel like I make up my own names. But it's called the supplement theorem. If you said definition of supplementary angles, I would count that too. They add up to 180. Yeah, I'm okay with it. Definition of linear pair. You don't know this already. But since we have our things right in front of us, I think we can say that's the supplement theorem. So we used our given to write an equation. Now look what we have. We're trying to show that angle 3 and angle 4 are congruent. Well, look at these two things right here.
Then you could say measure of angle 3 plus measure of angle 4 because of the difference.
We could do substitution. Audrey, what are you thinking?
I was gonna say, I don't know if they just said this, the congruent complements theorem. No, just kidding, congruent supplements theorem. Because instead of measure the measure of angle 1 plus measure of angle 2 equals 180, measure of angle 2 plus measure of angle 3 equals 180.
You're exactly right. All of you are right, just so you know. And that's what these proofs, that's what's hard about proofs. But the fact that we have a theorem that says this, if these two angles are both linear pairs or both add up to 180 with the same angle, then they have to equal each other, which means if you know that theorem, you could go straight to the answer right now, and the reason is the congruent supplements theorem. Let's say you forgot that theorem, which means you're exactly right too. You could do substitution there and show that they equal the same thing and get to the same answer. Both of those are correct. One's just shorter than the other. Does that make sense? If you know that there's a theorem that says this is true, it becomes a very short proof. 3 steps. You can say well, it says prove that angle 3 and angle 4 are congruent. We could say the measure of angle 3 is congruent to the measure of angle 4.
Wouldn't you have to?
Yeah, you also have to do the definition.
No, you wouldn't because they're just adding there.
If you look back at what the thing says, look at the previous thing we just did. What did it say? It says the theorem says if angle 1 plus angle 2 equals 180 and angle 2 plus angle 3 equals 180, then they are congruent. Like that's what the theorem says, which means you could actually just say that angle 3, I guess I don't need ends when I'm doing congruent. Angle 3 is congruent to angle 4 because of the congruent supplements theorem. Congruent supplements theorem.
Because it
It makes
says
perfect sense now.
that says it. That's why you just say it.
Because the theorem says that. If you didn't use that theorem and you use substitution or you worked it out, you're right. You have to do more work there. And it's okay if you do more work there, especially if you don't have this right in front of you. But the idea is, as we add these more theorems, our proofs can get shorter because we can use those theorems that have already been proven. Does that make sense? And so that's a 3-step proof, but just try to get you to recognize that you can use that. Does that help, Chandler?
Yeah.
I don't know if that makes perfect sense for like a sarcastic statement. That seems kind of sarcastic. But that's it, right? That's done. That's way shorter than the other, right? Alright, one more example and then just a bunch of theorems here. Vertical angles theorem. We've already talked about vertical angles. Vertical angles are when you have intersecting lines, not the ones that are next to each other, but the ones that are across from each other are vertical angles, right? And we knew that they were equal to each other. And now we just have a theorem that says that's true. If two angles are vertical, then they are congruent. Which again means if they give you given information telling you that two angles are congruent, that's your given. My very next statement would say they're congruent to each other based on that theorem. And that's just kind of the practice that we want to get to, is taking our given information and writing it out kind of in equation form. So it says angle 1 and angle 2 are vertical angles, and the measure of angle 1 equals d minus 32, and the measure of angle 2 equals 175 minus 2d. Find the measure of angle 1 and angle 2, justify each step. So again, justify means you don't necessarily have to do statements and reasons, but probably for everything you do, you should have a reason next to it, or an explanation next to it. So, what could I start with? If I know that angle 1 and angle 2 are vertical angles, what could I say? Yeah, they're equal. They're congruent to each other, right? Angle 1 is congruent to angle 2 because of the vertical angle theorem. Or I guess we could have, I mean, if we were doing a real proof here, we'd want to change congruent to equal, right? I'm gonna kind of make real proof here. I'm gonna say the measure of angle 1 equals the measure of angle 2. Definition of congruent. Then what would you do? Substitution, you already got my justification, right? I'm just going to substitute in that angle 1 is D minus 32. And angle 2 is 175 minus 2D. And that's exactly right. It's substitution. I was struggling at the beginning of the year to get you guys, some of you guys, to show work. This kind of forces you to show work, right?
I mean, you kind of in a way, because you kind of skim down to the next, to show.
Right, and I don't care if you show what you add to both sides. I just want more than an answer, right? But, so solve this now. Now this is your guys' favorite kind of proof, right? It's algebra.
Yeah.
So what do you want to do? Yeah, and technically since we're adding, we could add 2D and add 32 at the same time. That's the same property, so if you wanted to do them both at the same time, you could, or we could do it two. Do you want to do it both? So if we add 2D over, that would give me 3D, and if I add 32 over here,
200.
and again, both of those I added twice, so,
207.
sorry. And then we're just going to divide by 3, right? This is why we like these proofs, because our property is exactly what we're doing. We added. It's addition property. We divided.
And I'm on a skill as
I just not like
else
this because
figure out
they
what
don't
skill
involve
set
the
divided by
like
three is.
the theorems and all that.
It's
And that's a lot of your homework today. It doesn't say prove, it says justify, which means more than just answers on your homework. And then the very last thing I have for you is just a bunch of theorems about right angles. And part of your homework today asks you to prove these using some of the other theorems. And again, we can kind of talk through them, and then we'll talk about them on Monday of what questions that you have. But it says perpendicular lines intersect to form 4 right angles. You agree with that statement? How did you prove that? Because you probably could show that they make up linear pairs, and the only way they could all be linear pairs and all add up to 180 using the congruent supplements theorem is using that. All right angles are congruent. Because if they all equal 90 degrees, that means they all have to equal each other, right? What? Perpendicular lines form congruent adjacent angles. Lots of vocab here from chapter 1 in these. So it's just saying that if you have 2 lines, right, that are perpendicular, then angle 2 is congruent to angle 4, angle 1 is congruent to angle 3, angle 1 is congruent to angle 2, and again, that all goes back to those linear pairs that we know that they're going to make linear pair and add up to 180. If 2 angles are congruent and supplementary, then each angle is a right angle. If 2 angles add up to 180 and they equal each other, you agree that they have to be right angles. And again, you could write the proof out for that, and we're going to look at some of those on Monday.
So all the theorems you could prove, every single one of the theorems you could prove.
And every single one has a proof for it, yes. And so later on, after geometry, when you go on to other math classes, they give you lots of theorems, and sometimes, depending on who the teacher is, will prove it for you, or will show you in the book where the proof comes from, but every theorem in math there is a proof for, or you could prove it. If 2 congruent angles form a linear pair, then they are right angles. And again, has to do with the fact that they're a linear pair, they add to 180. If they're congruent, they have to equal each other, so it has to be 90 and 90. So there's lots of stuff about right angles. And again, I think there's a couple on your homework I gave you that asks you to prove theorem 2.10 or something, and you'll have to go back and look what it says and try to do a proof of it. A lot of your homework just says solve it, justify, so they're not like full formal proofs. But make sure that you do this weekend. This is the last section. The plan is that Monday we are going to review, well, mostly on Monday you're going to work on a review assignment in class, and Tuesday we will go over it and talk more in detail about it. Wednesday we will have our chapter 2 test. And then the week after that is the end of the 9 weeks, which means that's our only other test we're going to have this 9 weeks. Hopefully things will start picking up for us as we move on, but just know that that's our other big grade for this 9 weeks. So I think 15 and 22 are the only like formal proofs that I put on there. So a lot of the beginning ones, the even ones, are just about justifying your steps. Okay. So I think it'll be nice, refreshing after your frustration that you've had. Okay.